Alright, today we're going to continue with our patterns unit. Remembering our big idea is describing patterns in tables and in graphs can help us to solve problems and describe the world. Today our concept is going to be demonstrating and understanding that expressions can be used to express a pattern rule. So another way to tell what the rule is. Taking a look at the lesson 4 of your textbook. These are some examples of expressions. Which expression below would represent this number pattern? If you have 34, 35, 36, and it's counting up by 1, what would be a good way to express this pattern? Well, it doesn't start at 33. It starts at 34. So these are actually both out. And 34 plus t, and t is the part that we don't know. When we replace a number with a letter, that makes it an expression. Alright, so let's take a look at this rule here. To find the pattern rule that relates the input to the output, so we're doing an input to output rule. The pattern rule for the output is starting at 7, adding 4 each time, and remember we can use that to help us figure out what we need to do with the input to the output. So it's something with 4. Let's start with times 4, just because we can see that it is getting bigger. 1 times 4 is 4 plus 3 to get to 7. Let's see if it works. 2 times 4 is 8, plus 3 is 11. 3 times 4 is 12, plus 3 is 15. So that would be our rule. Plus 4 times 3. So input times 4 plus 3 would be our rule. Now, we can use an expression, use a variable in an expression to represent this rule. Let the letter n represent the input number. So it's 4 times n plus 3 would be how you would express this with a letter, with a variable is what we call it. It can also be 4n plus 3. If there's no sign between, we know that that means it's multiplication. And that would be expressing this rule as an expression. All right, we can use patterns to solve a problem. So here's our problem. Minowa works at a fishing camp in the Yukon. She earns $25 a day, plus $8 for each fishing net she repairs. On Saturday, she repairs 9 nets. How much money did she earn? All right, so we could use a table to assist us. Here we have the number of fishing nets and the amount earned. For 0 nets, she has $25 because she earns the $25 a day, plus $8 for each net, and she's repairing 9 of them. So for the first net, add 8, second net, add 8, third net, add 8, and so on. Then we would continue extending the table, and we would realize that she would earn $97 on Saturday after the $25 for the day, plus the $8 for each net that she's repaired. Now we could use an expression with a variable to show this rule. We know she earns $25 even if there are no nets repaired, and for each net she earns $8. So 8 times the number of nets that she repairs plus the 25 she gets for the day would be how we would express this rule. 8 times a letter plus 25. Now when we choose our letter, we want to be careful that we don't choose a letter that is going to look like a number. So choosing letters like O or S or T or X are not great choices because X looks like the multiplication sign, T can look like the plus sign, S can look like a 2, and so on. So it's better if you choose a letter that doesn't look like any other. Often people will choose N, but it can really be any letter that you like. So as an expression, 8 times N plus 25 would be our rule. We can then check if this expression is correct just by substituting the number of nets. So for example, 8 times n, we don't need the times sign, plus 25 was our expression. Assume we had 3 nets. 8 times 3 is 24, plus 25 does give us 49. And that was the number we had. Let's check for 9 nets. 8 times 9 plus 25. 8 times 9 is 72. Oops, sorry. Plus 25 does give us 97. So yes, our expression does in fact work. Remembering an expression represents the number with the variable, the operations, and the numbers. So that makes it an expression when it's a whole sentence, a number sentence. And a variable, remember, is a letter or a symbol that stands for a number you don't know. And again, when you're choosing your variable, do not choose one that will look like a sign or a number. All right, now is your opportunity to practice. Here's your problem. Keely builds model cars. She needs 4 plastic wheels for each car that she builds. Make a table to show the number of cars needed for 1 car, 2 cars, 3 cars, 4 cars, and 5 cars. Write the pattern rule that relates the number of cars to the number of wheels. Write an expression, so that's where you're using your variable to represent the pattern, and find the number of wheels needed to build 11 cars using that expression. And then you can check that. Press pause and try that now. All right, so I've created a table. Number of cars is on one side, number of wheels is on the other side. And for 1 car, we would need 4 wheels. For 2 cars, we would need 8 wheels. For 3 cars, we would need 12 wheels. For 4 cars, we would need 16 wheels. And for 5 cars, we would need 20 wheels. As you can see, this output to output is going up by 4 each time. Let's try 1 times 4, 2 times 4, 3 times 4. And in fact, that works every time. So that would be our rule. Number of cars times 4 equals the output. Now we want a letter to represent that, so we have an expression. So I'm going to put C because that's what we're talking about, the number of cars, times 4 equals the number of wheels. Now let's try that for 11. 11 times 4 equals 44. And then to check, we could extend our table to see if that's going to work. So I ran out of room there. I'm going to go 6, 7, 8, 9, 10, and 11 squished in there. All right, and if I check, I'm going by 4, up by 4 each time. So 20 plus 4 is 24, 24 plus 4 is 28, 28 plus 4 is 32, 32 plus 4 is 36, 36 plus 4 is 40, and 40 plus 44 is 40 plus 4 is 44. So 11 would have 44 wheels, and so yes, our expression does in fact work. All right, now you are on to your concept practice, page 22 to 23, numbers 2, 4, and 6. Remember, you are demonstrating and understanding that expressions can be used to express a pattern rule, so you need to use expressions, remembering to be careful what variable you use, that it is a letter that does not look like a math sign or a number. Remember, if you have any questions along the way, that you ask.